Hello, my name is Aisha and this is my presentation for my report in question 3 for Operating System Concepts BIT302. As an introduction, this report explores first Windows for desktop OS and Linux for Android, which is a mobile OS, and discusses the kernel, the interrupts, process and thread, and scheduling. So the kernel is the heart of an OS. So for Windows, the kernel is named Windows NT. So this kernel is included in Windows XP up to Windows 10. It consists of two main components. The first one, which is user mode, and the second one is kernel mode. The difference is in user mode, users are limited to programs and the subsystems, while in kernel mode, users have unrestricted access to the system memory and system devices. It is also a hybrid kernel, which means it has two layers. The first one, which is a simple kernel, and the other one is a hardware abstraction layer. In user mode, the executing code has no ability to directly access hardware or reference memory. The code running in user mode must delegate to system APIs to access hardware of memory. Due to this protection by this separation, the crashes in user mode are always recoverable. So in kernel mode, on the contrary, the executing code has complete and unrestricted access to the underlying hardware. It can execute any CPU instruction and reference any memory address. Not to forget, it is also reserved for the lowest level, most trusted functions of the OS. So crashes in kernel mode are really disastrous. It will halt the entire computer and stop the entire system from functioning. In Android, the Linux kernel is the foundation of Android. So it acts as an intermediary between hardware and software. The hardware developers enable the device hardware to interact with the kernel, and the software developers communicate with the kernel via API. It is a monolithic kernel, which means that it is just one program using one memory space. So the kernel in Android loads the app into memory, it creates the processes needed, it starts the app running, it allocates memory when the app needs it, it provides networking by doing all the low-level processing. It contains drivers for devices like Bluetooth. It handles background threads when the app needs to perform a task in the background. And it also lastly cleans up all the memory and other resources that were used by the app. Since Linux and Android is open source, it is cool that we can build a version of Android with a tweaked kernel according to our own settings. And then this kernel can be copied to our Android device instead of the default kernel. Next, we move on to interrupts. Interrupts are any signal that prompts the OS to stop work on one process and start work on another. So this will enable multi-process multitasking. In Windows, the hardware interrupts happen when an input-output operation is completed, such as reading some data into the computer from a disk drive, and software interrupts happen when an application program terminates or requests certain services from the OS. An interrupt request IRQ value is an assigned location where the computer can expect a particular device to interrupt it when the device sends the computer signals about its operation. When a printer has finished printing, it sends an interrupt signal to the computer. The signal momentarily interrupts the computer so that it can decide what processing to do next. A unique value must be specified for each device and its path to the computer. An OS usually has some code that is called an interrupt handler. It saves them in a queue if more than one is waiting to be handled. The OS also has another little program called the scheduler, which figures out which program to give control to next. In Android, the interrupt mechanism is inherited from Linux. Just like Windows, it enables devices to display that they need CPU attention. There are two types of IRQ in Android. The first one is a short IRQ. It is expected to take a very minimal amount of time, during which the rest of the machine will be blocked and no other interrupts will be handled. And a long IRQ, which can take longer and during which other interrupts may occur, but not from the same device, of course. Interrupt handler flexibility for Android, which is Linux OS, is achieved in two ways. The first one is IRQ sharing. The interrupt handler executes several interrupt service routines, which are called the ISRs. Each ISR is a function related to a single device sharing the IRQ line. So since it's not possible to know in advance which particular device issued the RIQ, each ISR is executed to verify whether the device needs attention or not. If it does, the ISR performs all the operations that need to be executed when the device raises an interrupt. Next, we have the IRQ dynamic allocation. An IRQ line is associated with a device driver at the last possible moment. For example, the IRQ line of the floppy device is allocated only when a user accesses the floppy disk device. In this way, the same IRQ vector can be used by several hardware devices even if they don't share the same IRQ line. Next, process and threads. A process is an executed program in the simplest explanation there is. A thread is the entity within a program that can be scheduled for execution. So, for process and threads in Windows, I'm going to specify on the process first and then the threads. It has a virtual address space, it has the executable code, it open handles to system objects, it has a security context, a unique process identifier, environment variables, it has a priority class, it has a minimum and maximum working set sizes, and at least one thread of execution. And each process is started with a single thread, often called a primary thread or a main thread, but can create additional threads from any of its threads. All threads of a process share its virtual address space and system resources. Each thread maintains exception handlers, a scheduling priority, thread local storage, a unique thread identifier, and a set of structures the system will use to store the saved thread until it is scheduled. Threads can also have their own security context which can be used for impersonating clients. Next, in Android, every program, which is your application on any Android mobile that runs on a smartphone, is contained within a process. A process has an ID known as the process ID. Short form for process ID. Short form is PID. It has a priority. It has its own address space. It has some state information, either running, sleeping, stopped, and zombie. The executable code inside the process on an app is a thread. When an Android application is first started, the runtime creates a single thread in which all application components will run by default. The thread is generally referred as to the main thread. The primary role of the main thread is to handle the user interface in terms of event handling and interaction with views in the user interface. Any additional components that are started within the application will by default also run on the main thread. Next, in the event that the code executing in a thread needs to interact with the user interface, it must do so by synchronizing with the main UI thread. This is achieved by creating a handler within the main thread which in turn receives messages from another thread and updates the user interface accordingly. Next, for scheduling, it is the allocation of a computer's processor power to a specific task. In Windows, it is used to prevent specific tasks from monopolizing all of a computer's processor resources. It assigns processors to different instances of Windows in virtual machines. It also shares CPU capacity with users connecting to a computer through remote desktop. Its objectives include first, efficiency. It keeps the CPU and other computer resources as busy as possible. If the CPU is left idle but there are jobs to run, everything will be slowed down. It minimizes response time for interactive jobs. It is essential to schedule this job first where the user is waiting for a response. Next, it reduces turnaround time. The average time, which is the average time taken to finish tasks, must be little as possible. There should be no starvation, which means the long-running batch task should also be making progress. It should have a low overhead, which means the schedule is already a process on its own, but it should not take excessive time. And next, also maximizing throughput. So throughput is the amount of tasks finished per unit time, hence it should be as maximized as possible. Next, in Android, the scheduling algorithm utilized in any OS based on Linux relies on the kernel. Android is an OS that utilizes an altered Linux kernel. Linux achieves multiprocessing by changing from one process to another in an extremely short time. This is done by process scheduling, which takes factors such as when to switch and which process to pick into account. The primary task is to schedule many unbiased runnable tasks on the CPU. The Linux schedule is a priority-based schedule that schedules tasks depends on static and dynamic priorities. Both of these priorities are merged to form a task goodness. Every time the schedule is executed, each task on the executed queue is inspected and its goodness value is determined. Then the task with the most goodness value is picked to execute next. Linux utilizes dynamically allocated process priorities for non-real time. Time-consuming processes have their priorities reduced. Processes that are on standby have their priorities increased dynamically. So the scheduling goals include quick response time, prevention of starvation, excellent throughput for background tasks, and support for real-time processes. So as a conclusion, in order to fully understand the similarities and also differences between Windows OS and Android OS, it is very important to form a study that explores all aspects of both Windows and Linux. This includes, but not limited to, the kernel, interrupts, process and threads, and scheduling. The way both of these systems operate are different, and this is shown by the disparities in intimacy between the OS functions. In the future, OS is believed to become dynamically evolving entities. So as each OS is developing further to suit everyone's needs, it is essential to study the foundation that makes up the entire OS and how each foundation works in the OS itself. Thank you.